The first Odyssey board lesson will guide you through the construction of a basic circuit with a switch. The following items are needed for this lesson: the Odyssey board base, 3 dowel rods, socket block, switch block used to open and close the circuit, 2 LEDs or light emitting diodes, a resistor jumper wire which is used to reduce the voltage down from 5 volts, 3 female to female jumper wires, color doesn't matter, 2 spade to female jumper wires. The most basic component of an electrical system is a circuit. There are 3 basic parts to a circuit: a power source, positive, like a battery or microcontroller, a load, which uses power, like a light or a motor, and a conductive path, which allows the current to flow to ground, or negative. To begin, slide one end of the resistor jumper wire with the end of another female jumper wire into one of the 2-hole spaces on the socket block. Be sure you insert them on the side of the block labeled back. The reason we use a resistor is that 5 volts is too much voltage for these LEDs and they will burn out. The resistor reduces the current's flow, similar to putting a kink in a water hose. Mount the microcontroller to the Odyssey board base using a dowel rod. Next, we will connect the wires to voltage and ground on the microcontroller. The row of blue pins labeled G are ground, or negative, and the row of red pins labeled V are 5 volts, or positive. Be sure not to connect to the very bottom row of blue pins, as they are not all ground. Connect the end of the jumper wire without the resistor to one of the ground or G pins. Connect the female end of the resistor jumper wire to a V or voltage pin. Next, insert the long leg of the LED into the voltage wire and the short leg into the ground wire or G wire. Since LEDs are diodes, electricity only flows in one direction. It is important that the long leg connects to V and the short leg connects to G. If the light is not oriented correctly, it will not work. Mount the socket to the Odyssey board base using a dowel rod. Now that we have created our conductive pathway connecting the power through a resistor to reduce the voltage to our load, which in this case is an LED, and then back to ground, we have made a complete circuit. Now connect the USB to the microcontroller and your computer. If your light comes on, you have done it correctly. If your light does not come on, check to see that your LED is turned the correct way with the long leg in the V wire and the short leg in the G wire. Also check your connections. If your light still does not come on, switch LEDs to see if the light is burned out. Before starting the next circuit, unplug the USB cord. Do not have your microcontroller plugged in when actively wiring. Next, we will create a circuit with a switch. A switch opens and closes a circuit. When the switch is off, the circuit is open and the current does not flow. When the switch is on, the circuit is closed and the current can flow through the load. Take the spade end of the jumper wire and plug it into the brass-colored prong of the switch. Plug the other end, the female socket end, into one of the G pins on the microcontroller. Take another spade end and plug it into one of the silver prongs on the switch. The female socket end of that wire and the female end of a resistor jumper wire should be fed into one of the 2 wire slots on the socket block. The other end of the resistor jumper wire should be plugged into one of the V pins. Now plug an LED's long leg into the V wire and the short leg into the wire coming from the switch. Now connect your microcontroller to your computer. When you turn the switch on, the LED should come on. If your light does not come on, be sure you connected a G pin to the brass-colored prong on the switch. Another jumper from a silver-colored prong on the switch to the short leg of the LED, and a wire is connected from the long leg of the LED running through a resistor to a V pin. You have created a complete circuit with a switch, which uses a voltage source, V, or positive, a load, an LED, and a complete pathway of conductors running to ground or negative.